Hello, Algebra 2 Honors. I'm sorry I'm not in school today, but I'll try to talk this worksheet through with you. So for starters, you can read over this warm-up. Maybe you want to shut off this video for a few minutes so you can spend a little time with it. So shut it off. Okay, so let's go. So let's see what we have. I have arbitrarily said A is equal to B. And then if you look at what we've done on both sides, it looks like going from here to here, all I've done is multiply both sides by A. Perfectly legitimate multiplicative property of equality. And going from the second step to the third step, clearly all I've done is subtract B squared from both sides. Again, subtraction property of equality. Going from the third to the fourth step, all I've done is factor both sides. Here I factored into difference of two, sum of difference, you know what I'm saying. And over here, I factored a B out of both terms. That's legitimate. It looks like over here, what's missing going from this step to this step is this A minus B. So it looks like I divided both sides by A minus B. Seems okay. This step to this step, I just substituted in. I rewrote this line, but instead of the B's, I substituted in A's, because in fact A is equal to B. And then this step to this step, A plus A is in fact 2A. And then to get to the last step, all I did was divide both sides by A. So it seems like everything's okay. Here's the problem. The problem is right over here. Here. Because I divided both sides by A minus B, and A is equal to B. And that's a problem. There is a multiplicative property of equality. There is a division property of equality for every single number, except when you multiply or divide by 0, in which case you can get something ridiculous, like we did here. So that's just one thing to tuck away. We're not allowed to multiply or divide by 0. Okay, topic 2. Look at these two things that we have here. On the left-hand side, notice there's no equal sign. So it's not an equation. On the right-hand side, we do have an equation. So on the left-hand side, if I wanted you to do something with it, I'd be asking you to add those fractions. So you know what you would do. Every single line is going to be a rewrite of the one that comes before it. But I can take that third fraction and factor the denominator, in which case I know my least common denominator is going to be x minus 2x plus 1. And what I'm going to do is combine them all, x minus 2, x plus 1. I'll need to adjust the first fraction by multiplying that 4x by x minus 2. In other words, I'm multiplying top and bottom by x minus 2, so form of 1. This middle fraction, I'm going to have to multiply the numerator by x minus 1. Sorry, that was x plus 2. And I don't have to do anything to the third. So as I go, I know this is going to give me 4x squared minus 8x minus 5x squared plus 5x plus 2 all over x minus 2, x plus 1. I can combine terms on the top, negative x squared minus 3x plus 2 over x minus 2, x plus 1. And the only thing I could possibly do to the top is factor out a negative 1, which I'm going to put up here, negative x squared plus 3x minus 2. And the bottom I can leave factored, x minus 2, x plus 1. Let me make that a little bit neater. And that's as far as we can go. Okay, the equation, though, is actually quite a bit easier. And I'm just going to rewrite it. Minus 5x, x minus 2 is equal to, and I'm going to factor the denominator here. So this is going to give us x minus 2 and x minus 1. And now, here's what I know we can do. With equations, we can just get rid of the fractions because we can use the multiplicative property of equality, which requires us to have an equation. So I'm going to multiply both sides by what we have in the denominator and distribute it. So when I go to multiply these two things together, x minus 2, Yeah, x minus 2, x minus 1 by this first fraction, well, I know my x minus 1s are going to cancel. So what I'll be left with is 4x, x minus 2. When I multiply these two together, I know I'm going to be canceling the x minus 2's, so I'll be left with minus 5x, x minus 1, and for these fractions, the entire denominator will cancel, leaving me just with 2. And I always leave things in parentheses and worry about distributing later. So now when I distribute, I get 4x squared minus 8x minus 5x squared plus 5x is equal to 2. So negative x squared minus 3x is equal to 2. That's quadratic, so let's set it equal to 0. Negative x squared minus 3x minus 2 is 0. I'm going to divide by negative 1. X squared plus 3x plus 2 is equal to 0, and now I'm going to factor this. X and x, let's see, plus 2 plus 1. So we get x is equal to negative 2, or x is equal to negative 1. And that's our answer. Okay, now I'm going to look at this next one, and I'm going to write it on the back of another piece of paper. So you might want to do the same thing. We need a lot of room for this. So for this next equation, we have x over x minus 2 plus 2 over x plus 3 is equal to 10 over x squared plus 6x, plus x plus x minus 6. Okay, let's do the exact same thing here. I hope you can see it, so I'm going to copy it over x minus 2 plus 2 over x plus 3 equals 10 over x plus 3, x minus 2. And now let's multiply both sides to cancel out the denominators. So x minus 2, x plus 3 on both sides. I know that right over here the x minus 2's cancel out, leaving us with x times x plus 3. Right over here the x plus 3's cancel out, leaving us with 2 times x minus 2. And over here everything's going to cancel. So that's just going to give us a 10. So when we just distribute, x squared plus 3x plus 2x minus 4 is equal to 10. X squared plus 5x minus 14 is equal to 0. X plus 7, x minus 2 is equal to 0. So x is negative 7, or x is equal to 2, which looks fine, but it's not. Because if we were going to go back and check, go back way to the original, this 2, in fact, unbeknownst to us, really is a problem. If I was going to go back and plug it into the top just to check, here's what would happen. I'm going to have 2 over 0 plus 2 over 5 is equal to 10 over 0, which completely does not make any sense. So the problem really was way back in the beginning. We had no idea what x was going to turn out being equal to, but over here, when we multiplied both sides by x minus 2, we were inadvertently multiplying by 0. So this, in fact, we get rid of. This is called an extraneous root. An extraneous root. Okay, so we only have one solution. This is the only thing we can use. So what you need to do whenever you have these, what are called rational equations, meaning that they have rational expressions, they're fractions. Whenever you have rational equations is go back and check your work. Make sure that the answer that you get is not going to give you a 0 in the denominator. Okay, now I would like you to do the next two questions. Talk to your any friend that you have in the room, and then check your work on the Moodle. Okay, good luck.